Adsorption. Adsorption is a concept which we come across in the chapter Surface Chemistry. It's an important chapter. So, adsorption is the phenomena of attracting and retaining the molecules of a substance on the surface of a solid or liquid, which will result in higher concentration of molecules but only on the surface. So this phenomena we term it as adsorption. So when we say only the concentration of the molecules will be on the surface, that is why we say that it is a surface phenomena, and the concentration of the adsorbate will increase only at the surface of the adsorbent. So here we come across two terms, that is adsorbate and adsorbent. So what is adsorbate and what is adsorbent? Adsorbent is nothing but the surface on which adsorption is going to take place, and adsorbate is the substance which is being adsorbed. For example, if we see water vapor adsorbed by silica gel, in this silica gel is the adsorbent and water vapor is the adsorbate. So here we should know about two more terms, that is desorption and sorption. Desorption is the process of removing an adsorbed surface or adsorbed substance from a surface on which it is being adsorbed. And sorption is when adsorption and absorption takes place simultaneously, we call it as sorption. Hence, there are various factors which may affect the process or the process of adsorption of gases by solid. So we could say the extent of adsorption of a gas on a solid will depend upon the nature of the adsorbate. So here we should understand that physical adsorption is non-specific in nature, and therefore every gas will get adsorbed on the surface of any solid, maybe to a lesser extent or a greater extent. Next factor which will affect is nature of the adsorbent, that is activated carbon, metal oxides like your aluminium oxide, silica gel, clay. These are considered to be the commonly used adsorbents. And when we talk about temperature and pressure, it is also a factor which will affect adsorption. As the temperature increases, adsorption will decrease. And if we talk about pressure, at constant temperature, the adsorption of a gas increase if there is an increase in the pressure. So these are all the factors which will be affecting the process of adsorption. And next, when we talk about, there are different types of adsorption like physical adsorption and chemical adsorption. So when we say physical adsorption, it is if the adsorbate is being held on a surface of the adsorbent by weak van der Waals forces, we call the adsorption as physical adsorption, or in short it is called as physiosorption. And next, when we say about chemical adsorption, here the forces holding the adsorbate is a strong, like just in the chemical bond. So the adsorption process we call it as chemical adsorption or chemisorption. So in detail, when we talk about physical adsorption, there are certain properties, that is it is non-specific, it will be reversible, and the amount of gas will depend upon the nature of the gas. That is, if we consider an easily liquefiable gases like ammonia, carbon dioxide, gas adsorbed to greater extent than H2 and He, that is, also we could say higher the critical temperature of the gas, more will be the extent of adsorption. So, we say that the amount of gas will depend upon the nature of the gas. And the extent of adsorption will increase with increase in surface area. So, for example, we could say porous and finely divided metals are considered to be good adsorbent. Hence, there are weak van der Waals forces of attraction between the adsorbate and adsorbent in physical adsorption. And also it will have low enthalpy of adsorption. So we could say low temperature will a favorable condition and no appreciable activation energy is needed, and also it will form multimolecular layers. That is about physical adsorption. And when we talk about the chemical adsorption, it will be highly specific and of course it will be irreversible in nature. And here the amount of gas being adsorbed will not be related to the critical temperature of the gas, and of course the chemical adsorption will increase with increase in surface area, because you are going to have a strong force of attraction just similar to the chemical bond, and it will have enthalpy heat of adsorption to be around 180 to 240 kilojoules per mole. And of course for this we require high temperature, and high activation energy is also needed sometimes. So here it will form unimolecular layers. So these are all the properties or the requirement for chemical adsorption. So when we talk about adsorption, it has certain application also in our day-to-day life. That is, it will be helpful in production of high vacuum, or it is used for controlling the humidity, like your silica and aluminium gel has the tendency of absorbing moisture and removing humidity. It can be used for gas mask or removing colored substance from solution. It is also used for separation of inert gases, and adsorption can also be used as an indicators. Then it is being used for the process of froth flotation process. That is, when sulfide ore is shaken with pine oil and water, the ore particles are being adsorbed on the froth that will float and the gangue particles will settle. Then it is also used in chromatographic analysis. And the most important, it is being used for curing diseases. Like some drugs can adsorb the germs on them and hence kill them, saving us from diseases. Thus, adsorption is very important even for curing diseases. It has multiple applications, but it is being used for even curing diseases.